Okay, you guys, we are starting chapter 8, like I said, sequences and series. This is an introduction to them. I don't know if you did this in Algebra 2 or not. Is today the 6th? 4/6/15. Go Royals. I don't know why my handwriting's so funny. Okay, so what is a sequence of numbers? In order. What kind of order? A numerical order. It can have a variety of different types of orders. So your guys' job is to be able to figure out what the pattern is, okay? So it's a list of numbers with a pattern. So basically we're going to talk about some vocab words today. We're going to talk about the word terms. A sequence has a variety of terms in it. So if we list 1, 5, 9, 13, 17, ... We know a couple things about this. First of all, we call the first term a sub 1, the second term a sub 2, a sub 3, and so forth. This is a sub 5. We can talk about a general term. Do you guys know what letter we use for something general? A sub n. Very good. A sub n is anything in the future, all right, or anything that we don't know. What do the 3 dots mean at the end? It means that it keeps going. So in this case, we're talking about an infinite sequence of numbers. If it doesn't have the 3 dots, then it stops. So it's a list of numbers with a certain order. That's what a sequence is. List of numbers. Curtis, I have a automatic one over here that works a little bit better.
I don't know if this pencil is long enough to use that automatic one.
Oh, okay. Do you need a new pencil? Here, world's best pencil, Ticonderoga. Don't say I never gave you anything. You're welcome. Okay, so sequence is a list of numbers that has a certain order. A series is we're gonna. You're fine. Go ahead. No, do it. Make their video longer. This is fun. Make them suffer. Okay, later we're going to talk about adding terms of a sequence together, and we use summation, and I just want you guys to start getting used to this symbol, and it stands for the sum. I don't know if we have it today in the rest of our notes, but we are going to talk about it quite a bit as this chapter goes on. Okay, there are times this list starts with a sub 1, but you're allowed to start with a sub 0 for convenience, okay? It just depends on what you're doing. So I know you guys often look for rules that are finite and you can't change them, but this one kind of has some flexibility to it. Okay, so we're already ready to start into examples because there's not a lot of vocab that goes with this chapter. So I'm going to go ahead and start with example 1. And I really feel like this chapter, I want to say that the mathematics is quite simple. But the procedures can be difficult to remember, okay? Where to start, what to start with, what you're going towards, okay? So the math, not complicated, but just kind of the new ways of writing things can be difficult. So this is find the first 4 terms of the sequence. And so what I'm going to do is I'm going to give you a general rule. And since it's a general rule, I'm going to write a sub n, because that stands for any nth term in the sequence, equals negative 1 to the n power divided by 3n over 1. I'm sorry, 3n minus 1. So your guys' job is simply to find the first 4 terms. You're supposed to find when n equals 1, 2, 3, and 4. So I'm going to make a list over to the side. We're finding a sub 1, a sub 2, a sub 3, and a sub 4. And it's simply plug-in numbers. The reason why I'm starting with this example, though, is because of the properties of the formula. What's that negative 1 to the n power going to make happen in the sequence?
Keep going from positive to negative.
It'll alternate from positive and negative numbers. And that's a good thing to know because at some point you guys are going to have to find the rule for a sequence that you see, and that can be complicated, okay? So thinking about what will happen when you look at a formula is important. Okay, so it's simply, all you have to do is write a sub 1, and since you're letting n equals 1, then in your formula you let n equals 1 equal 1. Simplify, you get negative 1 over 2. And that's the first term. It's really simple. Girls, find a sub 2. Boys, find a sub 3. I'll find a sub 4. Ladies, what'd you get? 1/5. Very good. Gentlemen? Negative 1/8. Okay, so it might help you to list these horizontally. It was negative 1/2, 1/5, negative 1/8, and 1/11. So you can kind of see a couple things happening. What's happening to your denominators? The denominators are increasing by what number specifically? 3, and that's because it has a 3 in that formula, 3n minus 1. It's oscillating, meaning negative, positive, negative, positive. Just a couple things to think about. You can do this on your calculator. There is a mode called sequence mode. So go ahead and make a little note. I'll show you here at the end. On your calculator, you'd hit mode. And then, I don't know if it says sequence. It probably just says SEQ. But it would be really helpful, not necessarily to graph on these. Sorry, I gotta stay close to you. What would be more helpful to look at? Not the graph. Not the equation. To find all of the values. If x equals 1, x equals 2, x equals 3, x equals 4. Starts with a T. Table. Okay, the table feature is very beneficial here. So go ahead and you'd type it in what would be y sub 1, but that changes, just so you know. And you'd use table feature. So y sub 1, because you're in a different mode, it becomes a sub n equals. And you type in what you need to. I'll show you at the end. Okay, so it's a little bit more difficult to go the other way. So example 2 is write an expression for the nth term. This is certainly the harder of the two, and it can be really hard and it can be really easy. And I think what you guys should think about as you go through this chapter is that I'm certainly going to give you the easier of the problems, and I might throw in one hard one that's multiple choice or one hard one that you have to do on your own, okay? I don't want you to be afraid of these. All right, so the first one is 1, 3, 5, 7. Just to give you guys some, I'm sure you could figure this out without doing any work, but I'm going to give you guys some ideas about how to get started if it gets harder. So n is which term you're looking at. So the first, second, third, and fourth term. Sometimes it helps to list those because your rule is dependent upon what term you're on. Then your sequence was 1, 3, 5, and 7. And sometimes what we do is we figure out what's happening in between our terms. So in this case, we're adding 2 each time. What kind of sequence is this? Can you guys tell? What kind of model would we use? It's linear. If we're increasing by the same value every time, that's considered linear. So I want you to keep that in mind. So it should look like a linear equation, y equals mx plus b. One hint is that if you see multiplication here in your formula, it's going to have to be one rule bigger. So bigger than multiplication or stronger, bigger than addition or stronger than addition is multiplication. So it kind of, if you see addition in your work here, then you're going to have to take it one step higher. So who's got the rule for this equation already? A sub n equals, think about making a linear equation out of that. Good job, Jared. 2n minus 1. And there are formal ways to do it, but I'm not teaching you the formal way today. You just kind of mess around with it. So if you plug in 1, 2 times 1 is 2, subtract 1. 2 times 2 is 4, subtract 1. 2 times 3 is 6, subtract 1. 2 times 4 is 8, subtract 1. Okay? So today you're just kind of messing around and seeing if you can figure it out. So this is what I'm looking for an answer. Finding a general rule. Okay, so then it gets a little bit more interesting when it's not linear. You guys have done linear all your life. We need to do other exciting things. So your sequence is 2, 5, 10, 17. Again, I like to put my ends down 1, 2, 3, 4 terms. First term is 2, this is 5, 10, and 17. And so, again, I want to reiterate that, I'm going to walk away. It's important because sometimes the numbers are related this way, sometimes they're related easily or more readily understood going this way, okay? So see if you can write down a formula for this one. And this is not everybody's cup of tea. I know that this is really hard, okay? It can be. That's okay. You'll get better. All right, who wants to do this one? Jared, are you good at these? N squared plus 1. Very good. Jared, they just come to him. And some people are like that. A sub n equals n squared plus 1. So let's look at differences here. The difference between 2 and 5 is 3. I'm sorry. Yeah, 2 and 5 is 3. The difference between 5 and 10 is 5. The difference between 10 and 17 is 7. And there is a pattern involved there. But what I want you guys to see is that you're not just increasing by the same number every time. You have to have something more powerful. So it's something squared. Okay. Another thing to note, I don't know if you've done this before, but the difference between 3 and 5 is 2. And 5 and 7 is 2. And that's where that squared comes from. Okay. All right. Let's go to the next idea. Okay, this is called a recursive sequence. It's just a special type. It's defined using previous terms. Again, you guys, not difficult math, difficult notation. Okay, you just have to learn. Defined using previous terms. Okay, so we're on example 3. Write the first 6 terms. We probably don't need to do 6. We will. Write the first 6 terms. So this one's going to look a little bit different. I'm not going to give you a list of numbers. I'm going to give you a list of rules. the first rule is that a sub 0 equals 1. Remember, I'm allowed to use a sub 0, or anybody is for convenience, okay? It just makes it start differently. The first term, a sub 1, is equal to 1. A sub k is equal to a sub k minus 2 plus a sub k minus 1. In order to start this process, k must be greater than or equal to 2. Okay, so when you guys see this in your textbook, or on your computer screen, I don't want you to freak out about all this stuff. It's very, very simple if you just start playing around with it, okay? So let's start our sequence. We're supposed to find the first 6 terms. So I'm going to just go over here and I'm going to start listing. What's the very first term? You don't use an A, just what's the very first thing that I'm going to start with? 1. This is the first one, a sub 0. 1. What's a sub 1? 1. Okay. I don't know if you need to make a note up here. A sub 0, a sub 1. We need to find a sub 2. Are we allowed to let k equal 2? Okay, so I'm just going to go right underneath here. I'm going to start plugging some things in. A sub 2 equals a sub 2 minus 2 plus a sub 2 minus 1, which really turns into a sub, what's this? 0 plus a sub 1. Do you have those two terms? Yes, so that's really 1 plus 1, which equals 2. Let's do another one. So I'm going to put a 2 up here. What should we find next? A sub 3. So you have to realize that you're letting k equal 3. You're using this rule right here. So that equals a sub 3 minus 2 plus a sub 3 minus 1. The third term, well, it's actually the fourth. A sub 3 is equal to a sub 1 plus a sub 2. What's happening? You're adding what always? The previous 2 before it. That's what that rule does. So a sub 3 is going to equal 1 plus 2, which equals 3. So you're always adding the previous 2 terms to get the next term. Hopefully at some point you realize that. So what's the next term? And then the next one? And what spectacular special name is this? It's the Fibonacci sequence. Have you heard of it before? Okay, so the only way that you can define the Fibonacci sequence is by using these recursive formulas. Okay, so this goes on forever, and it's really exciting, and we love Fibonacci. Fibonacci, Fibonacci sequence. Which, correct me if I'm wrong, and sometimes I have baby brain, so I can't remember. Golden ratio, is that also the Fibonacci sequence? Have you heard that? Okay, which occurs all the time in nature. It's really quite interesting stuff. All right, did we write 6 terms? 1, 2, 3, 4, 5, 6. Okay, so when you guys get to a recursive sequence on your homework, I want you not to be afraid to show work. If it doesn't come really naturally to you, then you absolutely need to do all this stuff in blue down here, okay? Okay, a couple more things for today. We're going to introduce a new word called factorial, which is used a lot, potentially in sequences and series, or it's used a lot in permutations and combinations, which fits under statistics. And I don't know how much you guys have done with statistics. They end this chapter on that, and I don't teach it every year. It just depends on how much time we have. Okay, so factorial is an exclamation point. And factorial occurs, you have to use a positive integer. You can't do factorials with anything else. So like you can't do -8 factorial. It has to be 7 or 12. Can it be 6.5? Can you do 6.5 factorial? No, because it has to be an integer, okay? So what n factorial means is it means that you're going to take and multiply 1 times 2 times 3 times 4. You're going to do this forever until you get to n. So you'll do it until you get to n minus 1, and then until you hit, oh sorry, that's not a comma, that should be a multiply, times n. We had to specially define 0 factorial so that we could use it. It always equals 1, which doesn't really fit with the definition. And you need to know that factorials have the same hierarchy as exponents. So if you're thinking of order of operations, think of them as an exponent. This formula looks awfully complicated for what it actually is. Example 4 today is to find 4 factorial first. And I don't go 1, 2, 3, 4. I always start with the number that it is and just work my way down. 4 times 3 times 2 times 1. Have you seen this before? Okay. There's a button on your calculator also. We'll find it in a second. Okay, so 4 times 3 is 12, times 2 is 24. That's the answer. Of course, it's going to get more complicated than that. 8 factorial divided by 2 factorial, 6 factorial. There will be a part on a quiz where I will want to see your work on this. I won't let you use your calculator. So what I'd want to see is I'd want to see you write down the top 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. No one's going to type that into their calculator though. Because on the bottom you have 2 times 1, and then times 6 times 5 times 4 times 3 times 2 times 1. And you guys are really just working with division. You get to cross all those off and do some mental math. So it'll be a non-calculator problem. So what's the answer to this one? 28. 56 divided by 2 is 28. Okay, on your calculator, the factorial button is, you go to math, then you go to PRB. What does that stand for? Probability. I didn't hear what you said. And then it'll give you the option to type in your factorial. However, I think you'll have to type in the number first and then do that. So you'd type in 4 up here and then go to math probability factorial. Is that it? No way. Hold on one sec. Oh no, that's not it. Almost done. Can I hit pause on this? Do you guys know? On the video? Okay. Okay, you guys, just a couple more things. The last thing we need to talk about today is called summation, and I already kind of showed you the symbol for it. This means add together all the terms. In the sequence. Or part. I guess you can do a partial sum. Okay, so give yourself a big Greek letter here. Which letter is that? Not epsilon. That's a good guess because it looks like an E. It's the one that was just in the news. Sigma. Sigma, alpha, epsilon. Okay, this is called sigma. It's a capital Greek letter. Usually there will be a number on top. I'm putting N. And there will also be a number on the bottom, and it will tell you where to start. Okay, so this is saying start with the first term and stop at the nth term. Then it will have a rule here. And what you'll do is you'll take each term, a sub 1, and add it to the next one, a sub 2 plus a sub 3, and you'll do this until you get to which term? A sub n.
Does it always start at 1?
It can start wherever it wants. Okay, it could do the 6th term through the 9th term. But what you're looking at right here is that this I and these I are related. Okay, so if it says that I is 1, then that means that you're starting with a sub 1. Okay. Okay, so maybe put a little, this is stop. This is where you start. Look at me, red and green. Isn't that cute? Okay, so here's your example for these. Again, the notation is the hardest part of this. We're going to do a summation from I equals 1 to 5 of the rule 3I. So what you do is this is a multiplication problem first. So it's 3 times 1. But your job is not only to write the terms, it's also to add them. So what would the second one look like? 3 times 2 plus 3 times 3. When do I stop? At 5. Oh, that's a 5, sorry. So 3 plus 6 plus 9 plus 12 plus 15. You don't need a calculator. 15 and 15 is 30 plus 15 more. 45. Okay, don't freak out when they give you this. We don't necessarily have to do it. I just want you guys to see it. Summation, big sigma, k equals 3 to 6. It's okay if they put a k down there. It's the same thing. But this isn't starting at 1. Then they have this rule here, 1 plus k squared. And then your job is to start over here and start writing what happens. So the first one would be 1 plus, what is k supposed to be the first time? 3 squared. Then you add that to 1 plus, what does k change to? 4 squared plus 1 plus 5 squared. When do I stop? 6. Do I ever do this to infinity? Why? No? Why don't I do this to infinity? You can't. Okay? You keep adding and adding and adding forever. You can't add something. You can't add certain types of sequences forever. Okay? There are types that you can. All right? The only time you can add together forever is when you multiply by a number that's what? Not 0. We'll get there. A number that's less than 1. A number that's getting smaller but staying above 0. Okay? All right, so last thing for today. Anyway, the answer to that is 90. You guys could figure that out later. 90. Okay, let's go ahead and talk about, last thing is the series. I know this is kind of long, you guys, but we got block days, so that's why we're kind of hitting a lot of things. This is sum, of infinite sequence. So it's kind of what I was just telling you can't do unless you have a special situation. So it either has to be a partial sequence or an infinite sequence. So if it's partial, that's like what we just did. The sum from I equals 1 to n, a sub I, a sub 1 plus a sub 2 plus a sub 3, going all the way to a sub n. Or, that's a partial, there is an infinite. It only works in special situations. It's the sum from I equals 1, and you put infinity at the top. And I have a really great video coming up this week for infinity and how to think about it. A sub I equals, careful here, a sub 1 plus a sub 2 plus a sub 3 plus dot dot dot. A sub I can be anything plus dot dot dot. It is essential that you guys start seeing those and realizing that that means infinity. Okay, so I think I've said the last example of the day like 6 times, but this, I promise, is the last one. Example. So the sum from I equals 1 to infinity of 3 over 10 to the I power. That doesn't look very good. Let's try that again. 3 over 10 to the I power. Okay, here's what it looks like. You write your first term, which is 3 over 10 to what power? Plus 3 over 10 squared. Plus 3 over 10 to what power? Cubed. What will happen on these problems, you guys, is that there will be a pattern that you will recognize. So you don't have to add forever. What is 3/10 as a decimal? 0.3. This is really 3 over 100, which is 0.03. This is 3 over 1,000, which is 0.003. And this is 0.0003. And if you add that together forever, what number are you reaching? 1/3. Okay, so this is approximately 0.3333, which is 1/3. Okay, I have an assignment for you on Google Classroom, or I'm going to put it up right now. Real quick, this assignment will be due on Wednesday. There are some problems, 39 through 51 odd, that I'm giving to you that are quite difficult. Those are the ones where you have to come up with the equation on your own, okay? I want you guys to test yourself. Do not go to CalChat too quick. Do not go to the back of the book too quick, okay? I want you to do trial and error. And then tomorrow we're going to do some in groups. So, actually, I think I'm going to write it down. So your homework is on page 577. It's due Wednesday. That'll be Thursday for hour 6. You're doing numbers, lots of numbers here, but I don't have any chunks. 1 through 7, 12, 24A, 38, 39 through 51 odd. That's the challenge part. 55, 67A, 71, 72, 87 through 93 odd, 103, 104, 108, and 117. Bye-bye.